Hi everyone. Let's convert from this descending powers form for the equation of a parabola, y equals 3x squared plus 12x plus 11, into this standard or vertex form, y equals a times the square of x minus h all plus k. Don't forget the square. And we'll find the vertex. Now, look at this. We'd like to get here the square of a binomial. And when I see something like the square of a binomial, I'm thinking CTS. What does CTS stand for? Completing the square. That process that we saw with equations of circles back in 0.13. Remember circles in 0.13. So what we're going to do is we're going to group the x squared and the x terms, and we're going to factor out a, which is 3 here. That's going to be our first step. Again, group the quadratic and linear terms. We're going to group together the 3x squared plus 12x, and we're going to separate out the plus 11. It's on its own. And then we're going to factor out a from this group. A equals 3, we factor out 3 from this group, but not the 11. When you factor, you divide. When you factor out the 3, you get 3 times the quantity, x squared plus 4x, and you have all of this plus 11. And don't forget the y equals over here. Now, bear in mind, you factor out a. You don't factor out the GCF. For example, we don't factor out the x. Also, what if we had had 3x squared plus 11x or 13x? You would still factor out the 3, in which case, instead of a 4, you might be getting 11/3 or something like that. And that's okay. You might get fractions. Don't be afraid of fractions. I was being nice here. When you divide 12 by 3, you get 4. I was being nice. But remember, you factor out a, that leading coefficient. If you end up with something like 11/3, too bad. You end up with 11/3. Okay. Now we're going to CTS, complete the square, and compensate. We have to pay for how we change the right-hand side. First of all, let's CTS. Let's complete the square. All right. So we take this coefficient on x, 4. It doesn't matter if it's positive or negative, but it is a positive 4. What do? Well, we take 4, and when we take half of 4, we get 2. Half of 4 is 2. And then what do? We square the 2. When we square the 2, we get 4 again, actually. So that means that in order to complete the square, we have to put a plus 4 inside the parentheses here, so that we end up with a PST. Remember, the goal is to make this thing a PST, a perfect square trinomial, so that it can be factored like this thing, the square of a binomial over here. But now wait a minute. We also have to compensate. We have to pay for what we do over here. We can't just throw in a plus 4 because we feel like it. And you have to be careful. How do we pay for inserting a plus 4 inside the parentheses here? A naive student might say, oh, well, I guess we subtract 4. Which I would understand, but you're being a bit naive. Because here's the problem. When we insert a plus 4 here, notice that there's a 3 out in front. Before, when we dealt with circles, we made sure that the leading coefficient was 1. We don't have that guarantee now. A equals 3 here. And guess what? The 3 impacts the 4. If you insert a plus 4 inside the parentheses, what are you really adding to the right-hand side? Not just 4, but 3 times 4. So when you insert the 4 in there, remember, you're adding 3 times 4. You're really adding 3 times 4 by the distributive property. When you insert the plus 4, you're really adding 3 times 4. You're adding 3 times 4. And how do you pay for adding 3 times 4 or 12? You subtract the 3 times 4 or 12. But don't forget, the 4 is getting hit by the 3, so you have to take that into account. It's a very common error to forget that. So to compensate for this, you have to subtract not 4, but 12. You can put 12 here. So next, since we should have a PST here by now, we need to factor the PST so that it looks more like this, the square of a binomial. How do you factor this PST? X squared plus 4x plus 4. Well, it is the square of x, now that middle sign matters, plus 2. Basically half of that coefficient on x. So we get the square of x plus 2 over here. Over here, 11 minus 12 gets us a negative 1. All right. So when we do the factoring, when we factor the perfect square trinomial, we get y equals 3 times the square of x plus 2, all minus 1. All right. Just for kicks, let's see if we got the right answer on desmos. Y equals 3 times x plus 2, x plus 2 all squared minus 1. All right, so I claim that the given equation graphs as that. What was the given equation? It was y equals 3x squared plus 12x plus 11. Y equals 3x squared plus 12x plus 11. Yes, they overlap. This is a graphical demonstration of equivalence. So it looks like we've gotten the right answer here. It's not a proof, but it's pretty convincing. All right. Oh, and by the way, where is the vertex? Where's the vertex? What is h, the x-coordinate of the vertex? Remember, be careful. Because remember, it's the square of x minus h. X plus 2 is x minus what? It's x minus negative 2. And all that's getting squared. So h is actually negative 2. Okay? You actually have to flip the sign. Remember, the sign is surprising. X plus 2, you might think you're moving right by 2 units. No, no, no. Remember, sign surprise when it comes to horizontal shifting. Horizontal shifting, the signs surprise. H is negative 2, not positive 2. You're doing a shift left by 2 units. K, however, you just grab the negative 1. You're moving down 1 unit. The vertical shift is very straightforward. So the new vertex will be at negative 2, comma negative 1. Remember, there is a sign flip from here to here to get the x-coordinate, h, but there is no sign flip for k, the y-coordinate. So watch out. Again, here on the graph, you can see negative 2, comma negative 1 is in fact the vertex. Now, what's a way of seeing that x equals negative 2 leads to the vertex? In fact, one way to look at it is that x equals negative 2 makes this equal to 0. Remember that trick with the equation of a circle? Remember that the center of the circle, h comma k, made the left-hand side equal to 0. It made both of these square guys equal to 0. Similarly, you want the value for x, or h, that will make this square thing equal to 0. And why is that? Well, remember, when you look at this vertex here, right? The vertex here is the most extreme point on the parabola. In this case, it's the absolute minimum point. It's the most extreme point on the parabola. It's the lowest point. Well, look at this square thing here. What is this square thing at its most extreme? What is the most extreme value of a square? You could say it's 0, because if you keep it real, squares are never negative. Squares are never negative. The most extreme this could be is 0. Okay. The vertex is the most extreme point on the parabola. Notice that 0 is the most extreme a square can get. So it makes sense that the value for x that makes this square thing equal to 0 leads to the extreme point on the parabola, because 0 is the most extreme value for this squared expression. So the axis of symmetry is x equals -2. Remember, it's the vertical line that goes through the vertex. X equals -2, h over here. And a equals 3, that's positive. We know the parabola opens upward. A equals 3, which is positive, the parabola opens upward. Next up, we're going to do some modeling. Given some points, find the parabola passing through them.